Hello, my name is Claudia Willmes. I'm a scientific editor at Cell. We are here today at the 87th Cold Spring Harbor Symposium on Stem Cells. Today with me is Taka. He's a professor at Cincinnati and University of Osaka in Japan. Welcome, and I'm looking forward to our conversation.
Thank you so much.
I'm very excited to be talking to you in person because
Likewise.
I have been reading your papers, and it's something else than reading a paper than talking to the person behind the science. So
That's awesome.
I remember very much a cover on Mad. There was a pig.
Oh, yeah.
And there were like oxygen bubbles coming up in the back, and so this was basically to depict the research that you published there on the I have to read that because enteral ventilation via anus. And so this was something fascinating, quirky science. Absolutely.
Thank you.
Though this is actually not really like
Stem
within
cell
scope,
topic?
as
Right.
scope of this
Happy
meeting,
to talk over
but still, I want to talk a bit because your talk you gave yesterday, the title was Understanding Interconnectedness in Liver Development and Disease. But the interconnectedness, I think, like you introduced this very beautifully. And so starting with a very broad question, so you have so many different exciting research lines. How do they connect?
Yeah, definitely. So, every experiment, every research program is somehow linked back to actual patients I have, meeting in the past. For example, for the liver disease, I actually have a friend who are, donating his, liver to his dad so that, his dad can recover from the liver failure conditions. But unfortunately, he's not able to survive. So that is kind of, my sort of, lifetime experience that I really wanted to provide the different cure for the patients with liver failure conditions. So that is kind of, initial inspiration why I got into liver biologies and trying to, potentially treat the liver disease patients population. Breathing program, on the other hand, is actually come from my dad. So my dad has very severe pulmonary infectious conditions, and still he's suffering from somehow. But like 4 years ago, he was actually infected by some pathogens like COVID-19 and developing ALDS conditions, which is a very serious respiratory failure conditions and potentially fatal conditions. And he was in ICU and needing some, mechanical ventilation supports, which is too much invasive. And also he has a, pulmonary problems as well behind the, ALDS conditions. So obviously it was a little bit of, a very unstable situation I have been experienced with. So I kind of decided to consider if there are any connections I can make in my, experience in the field of regenerative medicine. So that is kind of initial, motivation. I started on breathing program as well, using the digestive tract, which is my professional areas actually.
Mm-hmm. It is so inspiring that you drive, that your motivation is driven by personal experiences.
This is, because I'm not so experienced, I'm still in 30s and I don't have pretty much experience in the space, stem cell biology space. What I can do is leverage my own experience. So I think, I kind of intentionally try to link my research to my personal motivation or personal experience. So that is my main driver force.
Yeah, don't sell yourself short. Yesterday you presented some really exciting science. So
Thank you.
Yes, talking maybe about that a bit. So regenerating tissues and using stem cells to essentially, I assume, like the end goal is to build a new organ. Mm-hmm. So that is fascinating, complex. How do you make sure that because like to have a functional organ, in the end, you don't only have to have the cells that differentiate into the cells you need in the functional organ, but you have them at the same exact space they are needed, and they need to be connected and functional. So what are like the specifics you are working on in your, let's say, Grand Master Plan?
Yep, great. So, my talk title was interconnectivity. So we are interested in looking at what level of like communications or networks or connection is actually very important to drive the process of organ formation. For example, at the cellular level or even molecular level, there are lots of machineries where molecule is connecting to the DNA to activate the transcription programs so that we can change the cell fate. And that is pretty much of great discovery made by Dr. Shinya Yamanaka and also other many pioneering people who is jumping in the field, understanding transcription regulation. So even at the molecular level, there are lots of communication or connections that matter in the process of development process. And what I am most interested in looking at going forward is actually about maybe middle stage embryonic development process or maybe second trimester pregnancy process in humans. For example, pretty much of the developmental biology process or stem cell experiments is focused on the first trimester stage or very early stage of patterning events or specification events. But going forward towards organ formation process, we need to go beyond the early processes, right? And to move forward, I think the key is to understand more holistic view or more comprehensive view of how different organ system is communicating each other. For example, after like 9 days in mouse, after fertilizations, they are initiating the Claudia car, beating, right? Meaning there are lots of blood cells is perfusing the entire organ systems, and then also there are lots of nutritional, hormonal, endocrine cue is triggering the many different organ communications as well. So we definitely need a little more high level view or more holistic approach to just to enable further step of organogenesis to model. So that is exactly the stage we are so interested in looking at and then also understanding that, trying to model that process in iPS cells or embryonic stem cell culture system.
And so to grow, or I should say maybe to build a liver, so what is your starting material? What kind of stem cells do you use?
Yeah, we typically start from pluripotent stem cells, which is essentially looking like our embryo-like cells. So, for example, like embryonic stem cells, you can get the samples from the blastocyst stage, which is a very early stage of the embryo. And then we can get back in culture that has almost like universal potential to generate entire body parts in our body. So we essentially start from that pluripotent stem cells as the starting materials. So we typically spend like 20 or 30 or maybe a little longer 2 months culture, changing the different ingredients in a dish so that we can navigate the stepwise process of actual development process to be modeled in culture. So that is how it works in our stem cell differentiation experiments.
So you talked a bit about the timeline, so you said like 2 months, right? So at what stage, like how far can you grow?
Yeah, so obviously, just culturing the tissues is we can do that like even more than 6 months or even longer. But, the key is how we can make it more authentic and more holistic, as I mentioned in the previous, part. So we need to consider adding some additional elements. For example, liver is not just made by liver cells. We need to have vascular cells, we need to have mesenchyme supportive stromal cells, and we probably need a little bit of hematopoietic progenitor cells or stem cells because liver is actually a niche for blood forming cells. So we need to consider adding what sort of key elements needed to be added on in our existing differentiation experiments at when, right? So I think that, very complicated questions we need to tackle to just advance towards real organ formation process.
Yeah, that's very fascinating. So, I have one last question for you. So, for the students and early career researchers that are watching our conversation here, what would be the advice that you would give them for if they want to start a career in science?
Yeah, I think, something you think about in terms of hypothesis or experimental approach, probably some others can think in the same way. So you need to constantly creating new inventions or new perspectives or new insights. So, I think, something you don't have to think it alone, right? So you need to count on other people to brainstorm ideas and expand your ideas or amplify your approach. So my immediate suggestion, there are lots of suggestions I could make, but my top suggestion is talk to others. Even at the early stage of inception process or conceptualization processes, you need to challenge your approach, hypothesis or thoughts to others to see if the idea is really attract enough excitement or enough enthusiasm from others. So that iterative process is really evolving your hypothesis. So talk to the others. So that's probably my 2 cents.
Thank you so much for sharing your insights.
Thank you so much.
And thank you so much.
Thank you.